surface area and volume of spheres, hemispheres and composite shapes. A comprehensive guide to understanding and calculating the surface area and volume of three-dimensional solids. Common 3D solids. A solid in geometry is a shape with length, width, and height. It is not a flat shape. Some common solids include cuboid, cube, cylinder, cone, square-based pyramid, and sphere. The sphere. Definition. A sphere is a perfectly round three-dimensional object where every point on its surface is equidistant from its center. Real-world examples. Footballs, oranges, globes, and marbles are common examples of spheres. Key formulas. Formula 1. Surface area of a sphere. Surface area equals 4 pi r squared. This is the standard formula for the surface area of a sphere, where r represents the radius. The factor 4 pi comes from integrating over the curved surface of the sphere. Formula 2. Volume of a sphere. Volume equals open bracket 4 over 3 close bracket pi r cubed. This is the formula for the volume of a sphere. It is obtained by integrating the areas of circular cross-sections. The fraction 4 over 3 accounts for the three-dimensional nature of the sphere, and r cubed shows the dependence on the cube of the radius. Sphere formulas. Observe the formulas. Surface area, where r is the radius of the sphere. Volume, where r is the radius of the sphere. Example: FIFA World Cup ball. Problem: FIFA 2010 World Cup ball, Jabulani. The ball has a radius of 7 centimeters. We are asked to find the curved surface area of the ball, the volume of the ball. Take pi equal to 22 over 7. Step 1. Surface area. The formula for the surface area of a sphere is surface area equals 4 pi r squared. This is the standard formula for the curved surface of a sphere. Substitute r equals 7. Surface area equals 4 multiplied by pi multiplied by 7 squared. This is obtained by replacing r with 7 in the formula. Now replace pi with 22 over 7. Surface area equals 4 multiplied by open bracket 22 over 7 close bracket multiplied by 7 squared. This follows from the instruction to take pi as 22 over 7. Simplify 7 squared to 49. Surface area equals 4 multiplied by 22 over 7 multiplied by 49. This is derived from evaluating 7 squared. Cancel one factor of 7 in the denominator with one factor of 7 in 49. Surface area equals 4 multiplied by 22 multiplied by 7. This is simplified by dividing both numerator and denominator by 7. Now multiply. 4 multiplied by 22 equals 88. 88 multiplied by 7 equals 616. This is obtained step by step through basic multiplication. Final surface area, 616 square centimeters. Step 2. Volume. The formula for the volume of a sphere is volume equals 4 over 3 pi r cubed. This is the standard formula for the volume of a sphere. Substitute r equals 7. Volume equals 4 over 3 multiplied by pi multiplied by 7 cubed. This follows from replacing r with 7 in the formula. Now replace pi with 22 over 7. Volume equals 4 over 3 multiplied by open bracket 22 over 7 close bracket multiplied by 7 cubed. This is derived from inserting pi as 22 over 7. Simplify 7 cubed to 343. Volume equals 4 over 3 multiplied by 22 over 7 multiplied by 343. This is obtained by evaluating 7 times 7 times 7. Cancel one factor of 7 in the denominator with one factor of 7 in 343. This gives volume equals 4 over 3 multiplied by 22 multiplied by 49. This simplification reduces the fraction for easier calculation. Now compute the numerator. 4 multiplied by 22 equals 88. 88 multiplied by 49 equals 4,312. This is obtained step by step by multiplying 88 by 49. So the volume is 4,312 divided by 3. This results from combining the products in the numerator and keeping the denominator of 3. Now perform the division. 4,312 divided by 3 equals 1,437.3 recurring. This is derived by carrying out the long division, where the decimal repeats at 3. Final volume, approximately 1,437.3 cubic centimeters. The hemisphere. Definition. A hemisphere is exactly half of a sphere. It is formed when a plane passes through the center of the sphere and divides it into two equal parts. This definition follows directly from the meaning of hemi, which means half. Key formulas. 1. Curved surface area. Curved surface area equals 2 pi r squared. This is obtained because the surface area of a full sphere is 4 pi r squared, and half of that, the curved part only, is 2 pi r squared. 2. Volume. Volume equals 2 over 3 pi r cubed. This is derived because the volume of a full sphere is 4 over 3 pi r cubed, and half of that is 2 over 3 pi r cubed. Hemisphere formulas. 1. Curved surface area, CSA. The curved surface area of a hemisphere is half the surface area of a sphere. Surface area of a sphere equals 4 pi r squared. Half of that equals 2 pi r squared. This is obtained by dividing the total spherical surface by 2, since a hemisphere is exactly half of a sphere. 2. Total surface area, TSA. The total surface area of a hemisphere includes both the curved surface area and the circular base. Curved surface area equals 2 pi r squared. Base area equals pi r squared. Adding these together gives 3 pi r squared. This follows from including the flat circular base along with the curved part. 3. Volume. The volume of a hemisphere is half the volume of a sphere. Volume of a sphere equals 4 over 3 pi r cubed. Half of that equals 2 over 3 pi r cubed. This is derived by dividing the full spherical volume by 2. Final formulas. Curved surface area equals 2 pi r squared. Total surface area equals 3 pi r squared. Volume equals 2 over 3 pi r cubed. Example: hemisphere calculations. Problem: calculate the surface area and volume of a hemisphere with radius equal to 2 centimeters. Take pi equal to 22 over 7. Step 1. Curved surface area, CSA. The formula is curved surface area equals 2 pi r squared. This comes from the fact that a hemisphere's curved surface is half of a full sphere's surface area. Substitute r equals 2. Curved surface area equals 2 multiplied by pi multiplied by 2 squared. This is obtained by replacing r with 2. Now replace pi with 22 over 7. Curved surface area equals 2 multiplied by open bracket 22 over 7 close bracket multiplied by 2 squared. This follows from the instruction to take pi as 22 over 7. Simplify 2 squared to 4. Curved surface area equals 2 multiplied by 22 over 7 multiplied by 4. This results from calculating 2 squared. Now compute step by step. 2 multiplied by 22 equals 44. 44 multiplied by 4 equals 176. So the numerator is 176, and the denominator is 7. This is derived from multiplying in sequence. Now divide 176 by 7. This gives 25.14, rounded to 2 decimal places. This is the simplified numerical value of the curved surface area. Final curved surface area equals 25.14 square centimeters. Step 2. Volume. The formula is volume equals 2 over 3 pi r cubed. This is obtained because the volume of a hemisphere is half of the volume of a sphere. Substitute r equals 2. Volume equals 2 over 3, multiplied by pi, multiplied by 2 cubed. This is derived by replacing r with 2. Now replace pi with 22 over 7. Volume equals 2 over 3, multiplied by open bracket 22 over 7 close bracket, multiplied by 2 cubed. This follows from using the given value of pi. Simplify 2 cubed to 8. Volume equals 2 over 3, multiplied by 22 over 7, multiplied by 8. This is obtained by evaluating 2 times 2 times 2. Now compute step by step. 2 multiplied by 22 equals 44. 44 multiplied by 8 equals 352. So the numerator is 352, and the denominator is 21. This results from multiplying across the fractions. Now divide 352 by 21. This gives 16.76, rounded to 2 decimal places. This is the simplified numerical value of the volume. Final volume equals 16.76 cubic centimeters. Final answers. Curved surface area equals 25.14 square centimeters. Volume equals 16.76 cubic centimeters. Total surface area of a hemisphere. Problem. Calculate the total surface area of a solid hemisphere with radius equal to 3.5 meters. Take pi equal to 22/7. Step 1. Recall the formula. The total surface area of a hemisphere equals the curved surface area plus the plane circular base area. This is because the solid hemisphere has both a curved portion and a flat circular face. Step 2. Calculate the curved surface area, CSA. Formula: curved surface area equals 2 pi r squared. This comes from taking half of the full sphere's surface area. Substitute r equals 3.5. Curved surface area equals 2 multiplied by pi, multiplied by 3.5 squared. This is obtained by replacing r with 3.5. Replace pi with 22/7. Curved surface area equals 2 multiplied by open bracket 22/7 close bracket, multiplied by 3.5 squared. This follows from using the given value of pi. Simplify 3.5 squared. 3.5 squared equals 12.25. This is derived from multiplying 3.5 by itself. Now compute step by step. 2 multiplied by 22 equals 44. 44 multiplied by 12.25 equals 539. Divide 539 by 7 equals 77. This is simplified through multiplication and division. So curved surface area equals 77 square meters. Step 3. Calculate the plane surface area. PSA. Formula: plane surface area equals pi r squared. This is simply the area of the flat circular base. Substitute r equals 3.5. Plane surface area equals pi multiplied by 3.5 squared. This is obtained by replacing r with 3.5. Replace pi with 22/7. Plane surface area equals open bracket 22/7 close bracket multiplied by 12.25. This is derived from substituting pi and simplifying r squared to 12.25. Now compute. 22 multiplied by 12.25 equals 269.5. Divide by 7 gives 38.5. This results from basic multiplication and division. So plane surface area equals 38.5 square meters. Step 4. Total surface area. Total surface area equals curved surface area plus plane surface area. This is obtained by combining both contributions. Total surface area equals 77 plus 38.5. This is simplified by adding the two values found earlier. Total surface area equals 115.5 square meters. Final answer. The total surface area of the hemisphere is 115.5 square meters. Composite shapes. Composite shapes are formed by combining two or more basic 3D solids. Identify components. Break down the composite shape into basic solids: spheres, hemispheres, cylinders, cones, etc. Calculate separately. Find the surface area and volume of each component using appropriate formulas. Combine results. Add the results, being careful to exclude any overlapping surfaces when calculating surface area. Example: cylinder with hemisphere. Problem: calculate the surface area and volume of a solid made up of a cylinder with a hemisphere on top. The cylinder has radius 7 cm and height 20 cm. Take pi equals 22/7. Example: cylinder with hemisphere. Problem: calculate the surface area and volume of a solid made up of a vertical cylinder with a hemisphere on top. The cylinder has radius equal to 7 cm and height equal to 20 cm. Take pi equal to 22/7. Step 1. Surface area of the hemisphere. The formula for the curved surface area of a hemisphere is: curved surface area equals 2 pi r squared. This is half the surface area of a sphere. Substitute r equals 7. Area equals 2 multiplied by pi, multiplied by 7 squared. This is obtained by inserting the radius. Simplify 7 squared to 49. Area equals 2 multiplied by pi, multiplied by 49. This follows from evaluating 7 squared. Multiply 2 by 49 to get 98. Area equals 98 pi square centimeters. This is the curved surface area of the hemisphere only. Step 2. Surface area of the cylinder. The formula for the total surface area of a closed cylinder is area equals 2 pi rh plus 2 pi r squared. This includes the curved surface and both circular ends. But in this solid, the top circle is replaced by a hemisphere, so we only include one circular base at the bottom. Therefore, surface area equals pi r squared plus 2 pi rh. This is adjusted to exclude the top disk. Now substitute r equals 7 and h equals 20. Area equals pi multiplied by 7 squared plus 2 multiplied by pi multiplied by 7 multiplied by 20. This is obtained by replacing radius and height. Simplify 7 squared to 49. So the expression becomes pi multiplied by 49 plus 2 multiplied by pi multiplied by 140. This results from evaluating the square in the product 7 times 20. Simplify the second term. 2 multiplied by 140 equals 280. So the cylinder's surface area equals 49 pi plus 280 pi. This comes from simplifying both terms. Add the terms. 49 pi plus 280 pi equals 329 pi. This is obtained by combining like terms. So the surface area of the cylinder is 329 pi square centimeters. Step 3. Total surface area of the solid. Total surface area equals hemisphere surface area plus cylinder surface area. This is because the solid is made up of these two parts joined together. Total equals 98 pi plus 329 pi. This comes from adding the earlier results. Total equals 427 pi square centimeters. This is obtained by combining the two coefficients of pi. Now replace pi with 22 over 7. 427 multiplied by 22 over 7 equals 1342. This is simplified step by step through multiplication and division. Final total surface area equals 1342 square centimeters. Step 4. Volume of the solid. The total volume is the sum of the cylinder's volume and the hemisphere's volume. A. Cylinder volume. Formula. Volume equals pi r squared h. Substitute values. Pi multiplied by 7 squared multiplied by 20. Simplify. 7 squared equals 49. And 49 multiplied by 20 equals 980. So the cylinder's volume is 980 pi cubic centimeters. B. Hemisphere volume. Formula. Volume equals 2 over 3 pi r cubed. Substitute r equals 7. Volume equals 2 over 3 multiplied by pi multiplied by 7 cubed. 7 cubed equals 343. So volume equals 2 over 3 multiplied by pi multiplied by 343. Multiply 2 multiplied by 343 equals 686. So hemisphere volume equals 686 over 3 pi cubic centimeters. C. Total volume. Total volume equals 980 pi plus 686 over 3 pi. This is obtained by adding the two parts together. Convert to decimal approximation. 980 pi is approximately 3078.76. 686 over 3 pi is approximately 722.18. Adding gives about 3,800 cubic centimeters. Final answers. Total surface area equals 1,342 square centimeters. Total volume equals 3,800 cubic centimeters. Example. Cone on hemisphere. Problem. A wooden structure consists of a cone mounted on a hemispherical base. The vertical height of the cone is 24 centimeters, and the base radius is 7 centimeters. Calculate the surface area of the structure. Take pi equals 22 over 7. Example. Cone on hemisphere. Problem. A wooden structure is made up of a cone mounted on a hemispherical base. The vertical height of the cone is 24 centimeters, and the common radius of both cone and hemisphere is 7 centimeters. Find the total surface area of the structure. Take pi equal to 22 over 7. Step 1. Slant height of the cone. The slant height of a cone is found using Pythagoras' theorem. Slant height squared equals vertical height squared plus radius squared. So slant height squared equals 24 squared plus 7 squared. Slant height squared equals 576 plus 49. Slant height squared equals 625. Taking the square root, slant height equals 25 centimeters. Step 2. Curved surface area of the cone. The formula for the curved surface area of a cone is pi multiplied by radius, multiplied by slant height. Substituting values, curved surface area equals 22 over 7, multiplied by 7, multiplied by 25. The 7's cancel, leaving. Curved surface area equals 22 multiplied by 25. Curved surface area equals 550 square centimeters. Step 3. Curved surface area of the hemisphere. The formula for the curved surface area of a hemisphere is 2 multiplied by pi multiplied by radius squared. Substituting values, curved surface area equals 2 multiplied by 22 over 7 multiplied by 7 squared. That is, 2 multiplied by 22 over 7 multiplied by 49. This equals 2 multiplied by 154. That equals 308 square centimeters. Step 4. Total surface area of the structure. Since the circular base is not exposed, because the cone and hemisphere are joined at that circle, the total surface area equals the curved surface area of the cone plus the curved surface area of the hemisphere. So, total surface area equals 550 plus 308. Total surface area equals 858 square centimeters. Final answer. The total surface area of the structure is 858 square centimeters. Practice problem. Lead balls. Problem. How many lead balls, each of radius 3 centimeters, can be made from a lead sphere of radius 12 centimeters? Step 1. Idea of the solution. To solve this, we compare the volume of the large sphere with the volume of one small sphere. The number of balls is equal to the volume of the large sphere divided by the volume of one small sphere. Step 2. Volume of the large sphere. The formula for the volume of a sphere is 4 over 3 multiplied by pi multiplied by radius cubed. For the large sphere, the radius is 12 centimeters, so volume equals 4 over 3 multiplied by pi multiplied by 12 cubed. 12 cubed is 1728. So volume of the large sphere equals 4 over 3 multiplied by pi multiplied by 1728. Step 3. Volume of a small sphere. Again using the same formula, volume equals 4 over 3 multiplied by pi multiplied by radius cubed. For the small sphere, the radius is 3 centimeters, so volume equals 4 over 3 multiplied by pi multiplied by 3 cubed. 3 cubed is 27. So volume of a small sphere equals 4 over 3 multiplied by pi multiplied by 27. Step 4. Number of small spheres. The number of small spheres is equal to volume of large sphere divided by volume of one small sphere. That equals 1728 divided by 27. This division gives 64. Final answer. The number of small lead balls that can be made is 64 balls. Practice problem. Earth globe. Problem. A student was asked to paint an earth globe of radius 21 meters. A. What is the surface area of the globe painted by the student? B. If the globe is filled with liquid paint, what is the volume of paint used? Take pi equal to 22 over 7. Step 1. Formula for surface area of a sphere. The surface area of a sphere is equal to 4 multiplied by pi multiplied by radius squared. Step 2. Calculate the surface area. Here, the radius is 21 meters. So, surface area equals 4 multiplied by 22 over 7, multiplied by 21 squared. 21 squared equals 441. So, surface area equals 4 multiplied by 22 over 7, multiplied by 441. This simplifies to 5,544 square meters. Step 3. Formula for volume of a sphere. The volume of a sphere is equal to 4 over 3 multiplied by pi multiplied by radius cubed. Step 4. Calculate the volume. Here, the radius is 21 meters. So volume equals 4 over 3 multiplied by 22 over 7 multiplied by 21 cubed. 21 cubed equals 9,261. So volume equals 4 over 3 multiplied by 22 over 7 multiplied by 9,261. This equals 38,808 cubic meters. Final answer. A. The surface area painted by the student is 5,544 square meters. B. The volume of paint used is 38,808 cubic meters. Practice problem. Hemisphere bowl. Problem. A hemisphere bowl has an external radius of 18 centimeters and is made of wood that is 3 centimeters thick. Find the volume of wood in the bowl. Step 1. Idea of the solution. The volume of wood in the bowl is equal to the volume of the outer hemisphere minus the volume of the inner hemisphere. The outer hemisphere is formed using the external radius. The inner hemisphere is formed using the internal radius, which is the external radius, minus the thickness of the wood. Step 2. Determine the radii. The external radius is 18 centimeters. The internal radius is 18 minus 3, which equals 15 centimeters. Step 3. Volume of the outer hemisphere. The formula for the volume of a hemisphere is 2/3 multiplied by pi multiplied by radius cubed. For the outer hemisphere, volume equals 2/3 multiplied by pi multiplied by 18 cubed. 18 cubed equals 5,832. So volume of the outer hemisphere equals 2/3 multiplied by pi multiplied by 5,832. Step 4. Volume of the inner hemisphere. For the inner hemisphere, volume equals 2/3 multiplied by pi multiplied by 15 cubed. 15 cubed equals 3,375. So volume of the inner hemisphere equals 2/3 multiplied by pi multiplied by 3,375. Step 5. Volume of the wood. The volume of the wood equals the volume of the outer hemisphere minus the volume of the inner hemisphere. That equals 2/3 multiplied by pi multiplied by the difference of 5,832 and 3,375. The difference equals 2,457. So, volume of wood equals 2/3 multiplied by pi multiplied by 2,457. This is approximately 2,570 cubic centimeters. Final answer. The volume of wood in the bowl is about 2,570 cubic centimeters. Practice problem. Water cylinders. Problem. A measuring cylinder of radius 3 centimeters contains water to a height of 49 centimeters. If this water is poured into a similar cylinder of radius 7 centimeters, what will be the height of the water column? Step 1. Idea of the solution. When the water is transferred from one cylinder to another, the volume of water remains the same. So the volume of the first cylinder equals the volume of the second cylinder. Step 2. Formula for volume of a cylinder. The volume of a cylinder is equal to pi multiplied by radius squared multiplied by height. For the first cylinder, volume equals pi multiplied by radius 1 squared multiplied by height 1. For the second cylinder, volume equals pi multiplied by radius 2 squared multiplied by height 2. Step 3. Set up the equation. Since volumes are equal, pi multiplied by radius 1 squared multiplied by height 1 equals pi multiplied by radius 2 squared multiplied by height 2. The pi cancels from both sides, so radius 1 squared multiplied by height 1 equals radius 2 squared multiplied by height 2. Step 4. Substitute the values. Radius 1 equals 3, height 1 equals 49, radius 2 equals 7, and height 2 is unknown. So 3 squared multiplied by 49 equals 7 squared multiplied by height 2, that is 9, multiplied by 49 equals 49 multiplied by height 2. This simplifies to 441 equals 49 multiplied by height 2. Step 5. Solve for the height. Height 2 equals 441 divided by 49. This equals 9 centimeters. Final answer. The height of the water column in the second cylinder is 9 centimeters. Key formulas summary. 1. Sphere. Surface area. 4 multiplied by pi multiplied by radius squared. This gives the total outer surface of a complete sphere. Volume. 4/3 multiplied by pi multiplied by radius cubed. This represents the three-dimensional space occupied by the sphere. 2. Hemisphere. Curved surface area 2 multiplied by pi multiplied by radius squared. This is half the curved surface of a sphere. Total surface area 3 multiplied by pi multiplied by radius squared. This includes both the curved surface and the circular base. Volume. 2/3 multiplied by pi multiplied by radius cubed. This is exactly half the volume of a sphere. 3. Composite shapes. Break the solid into basic components such as cylinders, cones, hemispheres, or spheres. Calculate the surface area or volume of each part separately, using the appropriate formula. Finally, add the results together to obtain the total. This summary can serve as a quick reference sheet for solving sphere, hemisphere, and composite solid problems. Further practice. Assessment. 1. Find the surface area of a sphere with radius 1 cm to 3 significant figures. 2. Calculate the volume of a hemisphere with diameter 4 cm. 3. Find the radius of a sphere with volume 4,190 cubic centimeters. 4. Determine the diameter of a sphere with surface area 804 square centimeters. Further assessment. 1. A sphere has a volume of 1,000 cubic centimeters. Calculate its radius to 3 significant figures and find its surface area. 2. A hemisphere bowl has an external radius of 24 centimeters and is made of wood 3 centimeters thick. Calculate the volume of wood in the bowl. Volume of wood equals outer volume minus inner volume.